All right, guys. Welcome to another video. Here we are going to be talking about the second Project Euler problem. We're given the prompt: each new term in the Fibonacci sequence is generated by adding the two previous terms. We start at 1 and 2. The first 10 terms will be 1, 2, 3, 5, 8, 13, 21, etc. By considering the terms in the Fibonacci sequence whose values do not exceed 4 million, we need to find the sum of the even-valued terms. Now, if you don't know what the Fibonacci sequence is, you can go ahead and Google that. Different people start at different places. The most common one I've seen is starting at 1 and 1. Obviously, this problem has you start at 1 and 2, but other places start at 0 and 1. But basically what the Fibonacci sequence is you're given two numbers to start out with, and then each sequential number is the sum of the two previous numbers. So 1 and 1 make 2, 2 and 1 make 3, 3 and 2 make 5, 5 and 3 make 8, 13, 21, and 34. You will notice every third number when you do it like this is even. So we could use that sort of information. We are not going to, but that is a way to possibly solve this, because it must be the case that every third number when you start out with 1 and 1 is going to be even. And I mean, technically that's true of the other way. 0 is not really even, so you kind of have to ignore that. But when you do it like this, it's still every third number. It just moves, just the place moves by 1. And if you start with 1 and 2, it's every third number. It's just that it starts on the second one, and then you count, by 3. But it has to be that way because we start out with two odd numbers. Two odd numbers always sum to an even number. An even plus an odd always sums to an odd number. So you've got an odd plus an even here, and then you've got an odd plus an even here. That's going to give you two odd numbers in a row, which are going to sum to an even number. So that's how it works. That's how it has to work. It's always going to be the case that every third number is going to be even to infinity for the Fibonacci sequence. But like I said, we are not going to be using that bit of information. It is possible to write a function like that. So we're given can't exceed 4 million. I am going to call 4 million the boundary. You can call it whatever you want. That is going to be our parameter for this. Let sum equal 0. Return sum. Okay. Now, I don't think we could use a for loop here. We could probably use maybe two for loops, but I don't see us wanting to do that because that's going to add some complexity that we don't need. We're going to use a while loop. And why are we going to do that? Well, we've got to iterate somewhat strangely here. As I sort of mentioned, previously, the sequence iterates in a sort of strange fashion where each number is equal to the two previous numbers. So if we declare two variables instead, we're going to be able to sequence through the Fibonacci sequence because we need to have two numbers to add up for this next number in the sequence. So what are we going to go ahead and do here? Well, while I is less than the boundary, or j is less than the boundary, we are going to enter into this loop. Now, this is really to deal with in edge case. If you did the and here, you'd probably be okay, but there is going to be the situation where I could be less than 4 million, but j could exceed 4 million. And if we did and, it would exit out of that, not checking for I. We do want to check for I. So because of that, though, I is always going to be the smaller value the way that we're going to set it up. So we are going to need to check to ensure that it's less than the boundary. We don't technically need to check if j is less than the boundary, though. So we'll see that here in a bit. So if I is divisible by 2 with a remainder of 0, then we're going to do something. Now, what is this telling us? Well, it's telling us that if this is true, then I has to be even, because all even numbers are divisible by 2. It's always the case that an even number is divisible by 2. Odd numbers don't have something like that. There is no number for which all odd numbers are divisible by. And that has to be the case, otherwise there wouldn't be any prime numbers, right? All prime numbers except for 2 are odd. Let's check to see if I is less than the boundary again. Again, we're dealing with the one single number that could be, where I is less than 4 million and j is greater than 4 million. There's a possibility. I don't know. I haven't looked at the sequence and counted it up. But if it is, then sum is, and you saw this in my last video, the plus equal I. And now we want to iterate I, summing up I plus j now we can check B do the same thing. Sum j and j So what are we doing here? We're checking for 2 numbers through with each loop. So in the first round, we're checking by 1 and 1. In the first instance, this is going to now go to 2. And this is now going to go to 2. And because I is already at 2, j is now going to get set to 3. So in the second go around, we're checking 2 and 3. This is going to get changed to 5. And then because this is already changed to 5, j is going to get changed to 8. And then in the next go around, 13, 21. Right? Does that make sense? I hope so. So we need to now check to make sure. This works. Let's go ahead and console.log find multiples. We'll pass in 4 million. That's right. And there is your answer. So pretty straightforward. If you guys haven't seen a while loop before, it's very similar to a for loop. You just don't have to. You are only using that middle component in the parentheses. In the for loop, you've also got to declare a variable at the beginning and check a way to, or iterate through that. We don't really want to do that. I suppose if we wanted to declare two variables, we could, and we'd have to make sure that we're iterating through them, sequentially in the correct order. This is a little bit easier. I typically only use a for loop for one variable. I don't even know that you can iterate through two variables. Maybe you can with comma separation. Hope this video helps. You can obviously drop a comment in the video if you have any questions. But yeah, hope you guys enjoyed the vid, and I hope you guys check out all the other vids.